All right, here we go, guys. All right, let's see. I screwed the first one up, so let's check this one out again. All right, guys. So we talked about the other day. This worksheet one is all about slope and different things. So don't forget slope intercept form. Here it is for you guys. It can be rearranged like this. Don't forget, we don't use the famous and completely overused y equals mx plus b that much, but you need to know what it is. That b is the y-intercept and m is the slope. And we just take things like if the slope is -1/4 and our point is 5 and 3, we're just going to plug it. That's 1, by the way. 1/4. That's a horrible. Oh well, 1/4. That's supposed to be 1/4. So we end up with y minus 3 equals -1/4 over -1/4 times x minus 5. And then we just kind of leave it like that. We don't worry about it. So the idea is this, guys. So slope in itself, if you hear weird stuff going on, my office is next to the laundry room, which is next to the garage, which is next to probably the noisiest place on the planet. So if you hear weird noises, it's just that going on. So let's look at this. So we take a line like this, right? And in 7th grade, you were taught, oh, we got to run this way, like that. And then you've got to rise this way. And so you guys would go over and up, and that's just like not even close enough. You go, this would be our run. Let me go back to my pencils here. And I'm getting used to this thing again. So this would be our run. This would be our rise, is what we would look at. And that's rise over run. And then we got from 7th grade and we went to 8th or 9th grade. And they added this idea that if this is point x2, I'm going to actually do a different color for you guys. This is x1 and y1. And then this would be x2 and y2. And so how do I find the length of the run and the length of the rise? I'll go ahead and take those out of there. Well, I put it into an equation. I take the run and I do the largest value, which is x2, minus the smaller value, x1, and then I take the y's and I subtract those, keeping my pairs together. So if I use x2 first, I have to use y2 first. And that is my idea of rise over run. So we've turned this into rise over run. So then this in itself gets changed into the idea of, instead of writing the formula, we just want the difference in the y's, the change in the y's over the change in the x's. And so this is where calculus comes into play. We end up going to calculus from here, and we call it dy over dx, which is this. It's the same. dy is the change in y over the change in x, which is the same as y2 minus y1. That should be 1. Sorry, guys. Over x2 minus x1, which is the same as the stuff they taught you in 7th grade, which is rise over run. We just keeps moving along. So now we're headed towards this point here, which is a dy dx, okay? Now, dy dx is very specific. It is the slope. It is the change in y over change in x, but it is the slope at a very specific point on the graph. It's not just a long average one. It is a very specific point. You guys have been finding the average slope really over the entire line. So this is dy over dx is this point at the slope at a specific point. So we're still dealing with slope. And so those of you that are wondering, why do we have to learn slope so many years in a row? That's because we've gotten to this point where you can handle this class. So then we're dealing with perpendicular, and I'm going to deal with that one that I wrote up here. So the one up here is y minus 3 equals -1/4 times x minus 5. And then I want to write the perpendicular equation that goes through, let's make a different color. We'll go blue. That goes through the point 3 and negative 2. So first of all, I have to make my perpendicular slope, which is the negative reciprocal. So my perpendicular slope, so the perpendicular slope is equal to this fraction flipped over, 4 over 1. And we make it negative, multiply it by a negative because it's negative here. So what's negative times a negative? It's positive. So my slope is now 4. So I have my new equation. Y of the perpendicular line times the slope of the perpendicular line. So y minus my perpendicular line, y2 right here, is, or y1, it doesn't matter, just pick one, times a negative 2 equals my perpendicular slope, which is 4, and that looked like a 9, so that is just horrid, which is here. And then we are just taking our perpendicular line and finishing it out. And right here is the line to the perpendicular slope. The perpendicular line, let me rephrase that. The perpendicular line to this equation in green going through this point 3 and negative 2. I use this point and the negative reciprocal of this guy right here. Okay, so that's all they mean by perpendicular. And it's basically the same idea when it comes to parallel, guys. We just say y minus 3, and they say the slope is here. That's negative 1/4 again. We go x minus 5. But I want a parallel line through negative 1 and negative 5. So we come down here. That's our slope of a parallel line. Parallel means they're the same. So I'm going to do my y minus my y that they give me, which is this guy, equals my slope, which is the same for parallel, times my x minus the x they give me. And then there is my equation of a parallel line. All right. So these guys just mess people up. You get a line that looks like this, or you get a line that looks like that. Just understand that this is considered an undefined slope line. Undefined slope. So that means that there is no slope available. There's no nothing. It's not 0. So we end up with only x values. So it's going to be x equals whatever value this is. So if this was at 5, this would be x equals 5. That's what these guys look like, x equals 1. Those are the ones that go straight up and down. Okay. Now, when we're dealing with something that's flat and horizontal, that means it's flat, which means that our slope is equal to 0. So if it's equal to 0 and we deal with this here, we end up with a slope of 0 on the right side, which means that disappears and becomes 0. So we get y minus y1 equals 0. So these flat lines are whatever y value they give you. Y equals 1. So let's say the y value was, let's say it was through the point 2 and negative 3. This equation right here would be y equals negative 3, because all the y values are negative 3 and our x value always changes. So it'd be like negative 1 and 3, 5 and negative 3. So those are how that you deal with those. Absolute value. This is the bad boy that messes everybody's up. And even though we're way past absolute value, just understand that it's not this. No, it's like the absolute value. Oops, that's not an absolute value sign. Sorry, guys. Absolute value of negative 6 is equal to 6 because I get rid of the negative sign. No, don't just get rid of the negative sign. There is a reason that we do this. So the whole idea of absolute value is absolute value accounts for center and a distance. Okay? So if we look at this, center and a distance, distance is never negative. So this never is negative. All right. And I have a feeling I'm going to be erasing stuff because I got a little bit more than the room I gave myself. So center, this has to do with a center and it has to do with a distance, okay? So it's never negative. Distance cannot be negative. So if I'm facing Visalia and it's 7 miles away and Lindsay's behind me and it's 7 miles away, we don't say Visalia's 7 miles away and Lindsay's negative 7 miles away. No, we say they're both 7 miles away and I just happen to be in the center. So let's take that concept, and I'm going to erase this. Maybe I'm not very good at erasing right now, guys. It's not cool. So, oh, I'm getting better. Yeah, look at that. So this is the idea here, guys. All right. So let's just take this right here. So we have a center of 5. And then 3 away is 8. And 3 away is 2, right? So here's my center. So we say, okay, where did I originally start from? Well, I started from 5, right? I started from 5. Let me even show you something else. I started from x equals 5, and I've got this idea that I've traveled plus a distance, right? A distance, oops, of plus or minus 3. So if I move this over, I get x minus 5 equals plus or minus 3, right? Because the distance is plus or minus 3. Well, if I do 5 plus 3, I get 8. If I do 5 minus 3, I get 2. We don't write it this way. So we account for distance with the notation absolute value. So the absolute value of x minus 5 when it's equal to 3, oops, sorry guys, when it's equal to just 3 is how we account for this plus or minus 3. So when we solve these things, we have 2 different ways to solve them. One is the negative distance, x minus 5 equals negative 3, and the positive distance, which is x minus 5 equals 3. So x equals 8 and x equals 2. When we do this, look at that. The 2 is right here and the 8's right there. So that's where absolute value comes from. Now, when we're dealing with those, I really wish this would automatically erase when I did that. My other program did. Oh, well. So when we're dealing with those, we can, this doesn't erase very well, so I'm going to have to give myself more room. Oh, well. All right, that took way too long. That was irritating. You probably irritated watching it. Hopefully you fast forwarded through it. Okay, so when we're dealing with this, we're dealing with this absolute value piece here. So we end up with 2 equations, right? We end up with 2x plus 3. Let's go backwards. Can I backspace that? No, I can't. Control Z. Plus 3 is less than or equal to 10. And then we got 2x plus 3 is less than or equal to negative 10. Those are my 2 equations. So it's easy if we look at this right here. That's this half of the equation. And if I look at this one, that's this part of the equation. So I can make them all into one sometimes. Sometimes you can't. So it only works good on the left and the left side. So let's just tackle this. So let's solve from here. So if I just kind of work with this equation right here, I can subtract 3 from both sides. Let me get rid of this for you. All right. So I'm going to go back up here. Let's subtract 3. We're going to subtract 3 here. And so that means I'd have to subtract 3 and subtract 3. So that's negative 13. is less than or equal to 2x, which is less than or equal to 7. Divide everything by 2 to get it all pretty. And so we get negative 13 halves is less than or equal to x, which is less than or equal to 7 halves. Okay, so you can use this type of notation, or you can use this notation. This notation, which is a parentheses here, would be for greater than. This notation would be for less than. And then this next one over here would be for our greater than or equal to. So a bracket pointing this way is greater than or equal to, and a bracket pointing this way is less than or equal to. Okay? So when we're looking at this bracket, the x is larger. So what we're saying is that this is interval notation, that x is in between or greater than or equal to 13 over 2, which is less than 7 over 2. So my x is in between those. So rather than writing it out like this, they'll use this type of notation, which is interval notation. Okay, so this is called interval notation. So these two are equivalent. They mean the same exact thing. All right, guys. Last little piece here. All right, so we talked about this again for our opener, but let's just talk about function notation because it's going to be a big part of our daily lives. So remember, f of x, the question marks can be anything with the variable x in it. That's why the x is right there. Okay? So like this one, f of x equals x squared plus 2. But let's say x is equal to m. So instead of f of x, we get f of m. Well, if m is x, then we plug m in where x was, and we get m squared plus 2. Here's what I was talking about the other way. Well, what if m was g of x? So then we get f, the function f, with g of x stuck into it. So then we get, if you notice, let me do a highlighter, guys. I'm gonna try me a highlighter. All right. So if you notice, this form here is the same as that form there. X squared, except this is g of x squared, okay? Well, now we have to just define g of x. So let's say g of x was actually the square root of x plus 1. Then we would have to plug in x plus 1 wherever g of x was. So therefore, we would get the square root of x plus 1 squared. That quantity has to be squared plus 2. Well, what is the square root of x plus 1 quantity squared? It's just x plus 1 because the square root and the square, they're inverses of each other. It just disappears and it leaves you what's inside. Plus 2. So then we get plus 1 plus 3, which is horrible because I got that wrong. Bad. X plus 4 would be our answer. No. What did I do? Oh, go backwards. This is horrible. Are we having fun yet? Holy smokes. No. This is 3. Whoa, I know what I did. I did it in my head and I left it there. What am I thinking? Watch this. Let's see if I can white it out. No, that's not even white. Let's try this one more time. Can I white it out? Oh, I can. Look at that. It's like it wasn't even there, guys. My little whiteout button. So then this should be X. Ugh. You guys are making me nervous watching this video. Oh, man. Let's just do this one. Oh, hold on. I'm going to do this. I'm learning how to use this new one. Let's do that one. We're going to do a whiteout strip. There we go. Done. All right. So I got my red one here. So this should actually be, whoa, too big. Crazy. I'm going to just keep writing that just because we're at the end. So then this should be X plus 1 plus 2. And 1 plus 2 is 3. That was just way too long to get to that point. All right, guys. So that's the idea behind our function notation, our slope, and those different things. So that was just kind of a quick review. Kind of crazy. Hey, we'll see you soon.